Hi Logic students. I wanted to demonstrate a few things from section, wait, it's not 6.5, section 6.6. This is the section where we learn those forms of reasoning like modus ponens, modus tollens, so MP, MT, um, denying the antecedent, affirming the consequent, and so forth. There's a few things that I wanted to cover. The first one is that there really is no guesswork about what is valid and what is invalid. The forms that are valid are modus ponens or MP, modus tollens or MT, disjunctive syllogism, DS, and constructive dilemma, CD. There's also destructive dilemma, DD. So these forms are all valid. What is invalid is only denying the antecedent, DA, and affirming the consequent. Okay, so these two forms are invalid. We'll learn about them, but we learn about them to avoid them. And then later on, when we switch to chapter 7, these will drop out of the picture completely because they're not valid. But these are valid. So any argument that turns out to be an instance of modus ponens, modus tollens, disjunctive syllogism, or constructive dilemma or destructive dilemma is valid. These are valid forms. So let's see. I want to give you some examples. What you need to pay attention to before I talk about negations here. What I want you to understand is that each of these forms should be understood exactly as a form, that is, as a pattern that can have many different or an infinite amount, as a matter of fact, of exemplifications, of instances. Here's what I mean. Let's just state in general terms modus ponens. So modus ponens is this form of reasoning that if you have a conditional, if P then Q, and then as a second premise you have the antecedent of that conditional, P, you can infer validly Q. Okay. This is very intuitive. It's something that you've used a million times. If it rains, I'll bring my umbrella. It rains, therefore I'll bring my umbrella. So this will be stated as an instance of modus ponens here would be if it rains, then I'll bring my umbrella. It rains, therefore I'll bring my umbrella. So notice that here I use the capital letters of the English alphabet, but here I use the lowercase letters. It's a lowercase p, lowercase q, again lowercase p, and then q. This means that we're using these lowercase letters as variables for the formulae of our symbolic language. And so lowercase p stands for any formula whatsoever of our language, not just a letter, but even a more complicated formula. Suppose that you have something like this. Suppose you have if G then Q implies K or T. Then the second premise is if G then Q, and you infer K or T. Do you see that this is still modus ponens? I mean, modus ponens is the pattern of reasoning where you have a conditional up here, and then you have a second premise that matches the antecedent of the conditional. Exactly, there's an exact match between these two things. If that happens, then you can infer the consequent of the conditional by itself. That's what modus ponens does. So notice that down here, well, up here, a simple instance of that. But there's an instance of that even down here, even if it's more complicated. Down here, if G then Q is your P, and K or T is your Q. but the pattern is exactly the same. So you have this match, and you infer the consequent of the conditional. Okay, so notice that what modus ponens is, and all the other forms as well, is really a pattern. You know, you could represent it like this. If you have this type of structure, this is modus ponens. If you have something followed by a horseshoe, followed by something else, and then you have the first thing on its own, you can infer the second thing. Okay, but whatever goes in the circle or square, you know, anything can go there. So, for example, the presence of negations should not confuse you. If you had something like, if not G, then not T, not G, therefore not T. This is still modus ponens, even if up here, oh, sorry, this got erased. Even if up here, in the general statement of form of modus ponens, you don't see any negations. But remember, lowercase p, lowercase q, they stand for any formula whatsoever. So not G and not T are formulae of our symbolic language. So if you have something with negations, as long as there is the match, as long as you have that, then you can infer the consequent on its own. And this is how all of these forms work. Now, of course, see if I can add some space here. Well, I'll get back to rewriting. But of course, you know, different forms will work in a different way. Right? So here's modus ponens again. P, then Q, P, therefore Q. This is modus ponens. But modus tollens has a different structure. It goes if P, then Q, not Q, therefore not P. This is a different way of reasoning, but it's just as valid as modus ponens. So this is modus tollens. Well, think about it. The example I always give is if you, how do you know if the milk has gone bad? Say that you've had a carton of milk for a while in your fridge, and you want to find out if it has gone bad. Well, a simple test would is smell it. So, you know, you can say that if it has gone bad, if the milk went bad, then it smells. Suppose you smell it and it doesn't smell bad. You know that it hasn't gone bad. Okay, so if smelling bad is a necessary condition for the milk having gone bad, and that necessary condition is not met, then you can infer that the milk has not gone bad. So this pattern of reasoning is modus tollens. You have conditional, and you have the negation of the consequent of the conditional. Notice that in modus ponens, you have a conditional, and you have a second premise that is the same as the antecedent. Whereas in modus tollens, you have a second premise that is the negation of the consequent. And then you infer the negation of the antecedent. That's how modus tollens works. Okay, so an example of modus tollens would be, I don't know, this argument would be an example of modus tollens. Do you see it? The first premise is a conditional, so that's what you see in the structure of modus tollens. The second premise is the negation of the consequent of the conditional premise. The conditional premise has C as its consequent. So here the second premise is the negation of C. And what is being inferred is the negation of the antecedent. So A and B is the antecedent. So not A and B is inferred. And this is an example of modus tollens. Okay. So it is important to process the negations correctly here. In terms of rewriting, something that the book describes, here's what you should know. Sometimes, in order to see the form of a piece of reasoning more clearly, you can rewrite a formula, but it's not like you can rewrite things as you please. There are only two types of rewriting that you can do. What you can do is you can flip disjunctions. So anything that has the form P or Q. Sorry, my screen froze for a second. Let me get rid of that. Okay, anything that has the form P or Q, you can rewrite as Q or P. You think about it. You know, if you go to a restaurant and the waiter says, with your entree, you can have either soup or salad. That is the same as if he had said, you can have either salad or soup. Okay, so these are obviously equivalent to each other. S or D and D or S are the same. So you can always flip a disjunction. And the reason why it's helpful, it's useful to be able to do this, is that sometimes an argument will be, for example, an instance of disjunctive syllogism. But you can see it better if you flip the disjunction. Okay, so imagine that you have, well, first let's remind ourselves that disjunctive syllogism is this form, P or Q, not P, therefore Q. This makes sense. If you have two alternatives and the first one doesn't go, then it must be the second alternative. Okay, so if your brother is either in the kitchen or in the backyard, and it turns out he's not in the kitchen, then he's going to be in the backyard. So it's either in the kitchen or in the backyard, and he's not in the kitchen, he's going to be in the backyard. Okay, every time you have two possibilities and one doesn't go, the other one must be the case. So let's say you have an argument, let's use this one. So suppose you have S or D, and then you have not D, therefore S. I think you can see that this is an instance of disjunctive syllogism. Okay, but it's a little bit different from the form as it's stated on this side, because on this side you have the two alternatives, P or Q, and then what is being negated in the second premise is the first alternative. They infer the second alternative. But here what is being negated is D, which is the second alternative. Okay, so it seems like there's a little discrepancy between this form and the general, or the form of this argument, and the form of disjunctive syllogism as it is stated in general. So in order to see more clearly that this argument here is an instance of disjunctive syllogism, you can flip the first premise. If you rewrite the first premise as D or S, and then you supply the second premise, not D, for S, you can see at this point very clearly that this is disjunctive syllogism. Okay, so by flipping the first premise, you have a more exact match with the original form. But you're not changing anything, you're just rewriting the first premise so as to make it a little bit clearer that this is an instance of disjunctive syllogism. Okay, the other permissible rewriting at least in that section of our book, is double negation. So any formula that has the form P can be rewritten as not P. If you stick two negations in front of a formula, you're saying the same thing, only in a more roundabout way. So if you say it's raining, and then you say it's not true that it's not raining, that's just another way, more cumbersome and longer, but still another way of saying it's raining. Okay, so as long as you stick the two negations in front of a formula, you're saying the same thing. Again, double negation can allow you to see more clearly what is going on in an argument and what form is being exemplified. Suppose that you have this, if G then Q, I'm sorry, that's not what I had in mind. If G then not Q, and then you have Q as the second premise, and you infer not G. You should be able to see that this is a modus tollens, right? Here's the form of modus tollens. You have a conditional, and the second premise is the negation of the consequent, and you infer the negation of the antecedent. Okay, so when the second premise clashes with the consequent of the first premise, you can infer the negation of the antecedent of the first premise. And this is the same thing that is going on this side. Q and not Q clash with each other. Okay, and if you need to see that more clearly, you can rewrite Q as not Q. Okay, so really what is going on is that the second premise is the negation of the consequent of the first, because not Q is the negation of not Q. Okay, but if you add something like you know, if G then not Q, therefore not G, this wouldn't be modus tollens, because in order for modus tollens to happen, the second premise must be the negation of the consequent of the first. And here there's no negation. The second premise is simply a repetition of the consequent of the first. Not Q is up there, and not Q is the second premise as well. So you need to see a clash between the consequent of the first premise and the second premise. And that means that the second premise must be the negation of the consequent of the first, and then you can infer the negation of the antecedent. Okay, I hope that this helps. Let me know if you have any questions. Thank you very much.